Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this class we are going to discuss another question on graph, that is minimize malware spread, right? So in this question we are given a node of a network of n nodes represented as n cross n adjacency matrix graph. So adjacency matrix is another way to represent the graph, right? So adjacency matrix is given to you where the ith node is directly connected to the jth node if graph of ij is 1. So an adjacency matrix graph is given, right? So this is like you are given this matrix, right? So this is an n cross n matrix. These are the rows, these are the columns. So if graph of ij is 1, then this means that there is a direct node between I and j. So if graph of 1 1 is 1, so this means that there is a direct node from 1 to 1. So if graph of 1 2 is also 1, so this means that there is a direct node between 1 and 2 in the network, right? So the representation, this is another representation of graph, right? So this adjacency matrix is given to us, right? Next is the nodes are initially infected by malware whenever two nodes are directly connected and at least one of those two nodes is infected by malware. Both nodes will be infected by malware, right? So initially a 1D array is given to you, right? So the whatever nodes are present in this array, these nodes are initially infected by the malware, right? So if there is a two nodes are infected, there is a direct edge between two nodes. So if there is a direct edge between 0 and 2, then if 0 is connected infected by malware, the 0 is infected by malware, then 1 2 also becomes infected by malware. So this infection spreads, right? This spread of malware will continue until no more nodes can be infected in this manner, right? So if now some other node is connected to 2, another node is connected to 4, then because of 2 3 will become infected, because of 3 4 will become infected. So this infection continues until no more nodes can be infected, in this manner, right? So in this way the nodes can be infected. So initially in the initial array, the nodes are given which are initially infected, right? So m is the final number of nodes infected with malware in the entire network, right? So m is representing the total number of nodes infected in the network in this way, that is in way this infection spreads, right? In this way, when all the nodes are infected, then m is representing the total number of nodes infected by the malware infection, right? Next is if removed. Now from the initial array, you can remove exactly one node, either this or this. If removed would minimize m, then you have to remove that node from the initial array by the removal of which m becomes minimum. So you have to minimize m. That is, you have to minimize the infection. How? By minimizing the total number of nodes infected by this malware spread, right? So you have to choose that node from the initial array by removal of which your m becomes minimum, right? So note that if multiple nodes could be removed to minimize m, return such with the smallest index. If two nodes are minimizing the same value of m, then return the node with minimum index. So if 1 and 2 are because of the removal of 1 and 2, the m is minimizing with the same value, then return 1, that is return the smallest index, right? Also it is given that note that if a node was removed from the initial list of infected nodes, it might still be infected later due to the malware spread. For example, you are given these nodes 0, 1, 2, 3. Now 0 is infected. For example, initially 0 and 2 are infected, right? So all of these are infected, right? So because all the nodes are either directly or indirectly connected to the infected nodes, right? So if I remove 0 from this initial, this means that now 0 becomes uninfected, right? So now 0 becomes uninfected. Now only 2 is infected, right? So it is given that 0 can now again become infected due to some other infected node. So now 0 becomes infected. 0 will again become infected due to this 2. Why? Because of 2 1 will become infected, because of 1 0 will become infected. So 0 can again become infected due to some other infected nodes, right? So for example, let's take an example. I hope the question is clear to you that we can remove exactly one node from the initial, and we have to remove that node by the removal of which our m becomes minimum, right? So we have to minimize m, that is we have to minimize the total number of nodes that can be uninfected by the removal of one infected node from the initial list, right? So let's take an example. For example, you are given this network, right? So initially 1 and 5 are infected, right? For example, initially 1 and 5 are infected. So because of 1 2 is infected, because of 2 3 is infected, because of 5 4 is infected. So our m is what? The total number of nodes infected. Now the malware can't spread more, right? So the total number of nodes infected are 1 2 3 4 5. So the total number of nodes infected is 5, right? Now if I remove 1 from this initial, that is now 1 becomes uninfected, right? So 1 becomes uninfected. So because of 1 2 will become uninfected, because of 2 3 will become uninfected. So now this component becomes uninfected. Now the total number of infected nodes are only 2, right? So next is, if I remove 5 from this, then because of 5 becomes uninfected, and also 4 becomes uninfected, right? But now 1 is there, right? So these 3 are infected. Now the infected nodes are 3, right? So you have to remove which node, by the removal of which your m is becoming minimum, right? So you can see that by the removal of m, your m is becoming 2. By the removal of 5, your m is becoming 3. So you have to minimize m, so you have to remove m 1, right? So you can remove 1 so that you can minimize the total number of infected nodes due to malware spread, right? So we have to minimize this m, right? So let's take another example. For example, this is 1 2 3 4 5 6 7 8 9 10 11. Let's suppose initially the infected nodes are 1 5 7 and 10, right? So initially these are infected. Now because of 1 2 is infected, because of 2 3 is infected, because of 3 4 is infected, because of 4 5 is already infected, because of 5 6 is infected, because of 7 8 is infected, because of 8 9 is infected, because of 10 11 is infected, right? So all these nodes are infected. The total number of infected nodes are 11, right? Now you can remove one node from this initial, right? So let's start from 1. Now if I remove one node from this array, that is this graph, then so if I remove 1 from this graph, then 2 will become uninfected, but now 2 again become infected due to 5, right? So 4 becomes infected due to 5, 2 again become infected because of 4, and now 1 again become infected due to 2, right? So the total number of infected nodes remain same, right? So the removal of 1 is not beneficial for us. So let's move to the another node. Total m is 11, right? If I remove 5, then because of 5 4 and because of 4 6 and 2 will become uninfected, but because of 1 again 2 will become infected, and now 2 infects 4 4 infects again 5, and 4 infects 6 also, right? So again after the removal of 5, our total number of infected nodes remains unchanged, right? So it is not beneficial to remove 5. Now if I remove 7, now 7 becomes uninfected, right? So let's use green color for uninfected. Now 7 becomes uninfected. Because of 7, 8 also becomes uninfected, because 8 cannot be infected by any other node. Now 9 also become uninfected. Now the total number of infected nodes remain 6 plus 2, 8. So now after the removal of 3, the total number of infected nodes are 8. Now let's check for this. If I remove 10, now these again become infected, right? So if I remove 10, because of this the number of infected nodes remains 8. Because of this 11, because of 5 also 11, right? Now if I remove 10, then 10 becomes uninfected, and 11 also becomes uninfected, because 11 is not infected by any other node, infected node, right? So both of them become uninfected. So now the total number of infected nodes remain 9, right? So after the removal of 10, 9 nodes are infected, right? So we have to minimize M, that is we have to minimize the malware spread, that is the total number of nodes infected by malware. So we will choose this, that is we will remove 7 from this initial. The answer will be a 7, right? So we have to solve this question in this manner. Now what are we doing, that we are grouping the components of graph, right? So will do what, we will find the union function for this graph, right, for the given network. Now union function will do what, union function will group the graph into different components and also help to find the size of this group, right? So union function will also find the size of all these groups. Now which size we will choose, we will choose the size that is maximum. We will choose that group in which if I remove the infected node, then the total number of infected nodes become minimum. So if I will choose the maximum, I will choose the biggest group, right? So union function will help me to divide this graph into group and also give me the size of the each group, right? So let we move to the code part. We will firstly do the find the DSU, right? That is the union function. So for this we need what, we need a parent array as well as the size array, because we want size also. So let's declare them global parent and vector int size, right? So parent dot resize, let's initialize them here. So we will resize them to n, both size and vector, the both size and the parent array, right? Resize them to n. Next we will move in the adjacency matrix, right? So let's move in the adjacency array, that is graph, right? Let's store the length of this graph in some variable. This is, since this is of n cross n, so the number of rows and columns are same, right? So let's initialize them here, right? So this will go from 0 to n. So we will find the union function, right? So we will find the parent of I, but before this we will find this only if the edge is present between the two nodes, right? So firstly we will check if graph of ij is 1, right? If 1 is there, this means that a edge is present between them. Then find the parent of x and y, that is find the parent of I and j, right? Find the parent of I and j if the parent of them are not same. then merge them, merge their parents, right? So this for loop will give me the connected components and also give me the size of the connected components, the groups, right? So this for loop will give me these components. This is the first group, this is the second group, this is the third group, and also the size of these groups, right? So for this we will have to write the find and the merge function, right? So let's first write the find function, right? So this is of type int find and we are passing a node, right? So find the parent of x. If parent of x is x, then return x, else find the parent of x. That is the ancestor of x, right? So mark it to the parent of x and return the parent, right? And return the parent. Next we have to write the merge function. A merge function is of type void. We are passing parent 1 and let's name this as leader x and leader of y, right? So parent 1 and parent 2 we have to merge them. So if the usually we don't merge the union function on the basis of size, but in this question we are going to do this on the basis of size, right? So if size of leader of x is greater than size of leader of y, then mark the parent of leader of y as leader of x and also increment the size of the this parent, this group, right? So increase its size, else mark the parent of leader of x as leader of y and increase the size of this group, leader of y at the size of the second group, right? So we are merging these groups, right? Next is now these functions and but before this one thing is remaining, that is we have to initialize these two vectors, right? So we have to initialize the parent and the size vector. So initialize the parent vector with the nodes itself. The parent of the node initially is the node itself and the size of each node is 1. Initialize the size with 1, right? So now this for loop will give me the groups. It will divide the graph into the groups. Now one more thing to notice here is that for example, if more than one infected node is present in a group, that is in this group 1 is also infected, 5 is also infected, then if I remove 1, then 5 will make 1 infected again and all these nodes, and if I remove 5, 1 will make all these nodes and 5 infected again, right? So if more than one infected node is present in a group, then there is no need to remove that node, since it is not going to help us in minimizing the number of infected nodes, right? So we have to take in care of the number of infected nodes present in a particular group, right? So we will make a vector of type integer and name this as infected. This is of size n, right? So we will move in the initial vector. Let's use this for loop, right? So find the parent of initial of I, right? So find the parent. Next is mark the parent of each. The maximum value is n, so mark the parent of each by the number of infected nodes in this vector, in this array. Mark the parent of each with the number of infected node, each group with the number of infected nodes present in that group, right? So in the infected of p, increase it with 1, right? So it will contain, now infected group will contain the number of infected nodes present in a particular group, right? Next is find the answer. Find the answer. Now we will choose the group which is having the maximum size and in which all the only one infected node is present, right? Only one initial infected node is present. So again I will move in the initial array, right? So firstly find the parent is equal to find the, oh sorry, here also find the parent of the node. Find the parent of the node, right? If infected of that parent is equal to 1, that is only one and that is only one infected node is present in that group and the size of that group is size of parent is greater than or equal to the max size. That is, we have to choose the group which is having the maximum size, right? Oh, here mark it with 0 otherwise, right? Next is if infected of parent is 1, that is only one infected node is present in the group and the size of that group is greater than the max size, then check if the size is equal to the max size. That is, both the nodes are equally contributing in minimizing the malware effect. That is, if I remove any of the two nodes, the number of infected nodes remain same. In that case, return the minimum, right? So return answer will be what? The minimum of answer and the initial of I, right? Initial, right? Next is else, answer will be what? E, that is initial of I. That is, we have to remove that node, right? Why? Because the size of that is also maximum and that is maximum size means if I remove that node, then I will make maximum number of nodes to be uninfected, right? Else now we have to update the our max size, update the max size to the size of parent, right? So this will give us our answer. Next we have to check that if we are not able to find the answer, that is answer is now still -1, then we have to return the minimum value, that is the smallest index. So take a min here, mark it with maximum value, that can be n+1, right? So move again in the initial array and find the smallest index. Initial dot size I plus plus min is equal to min of answer min and the initial of I. Let's name this as small, right? So small, small, and here also small. Small, right? If this is not true, in this case return the small, that is the smallest index, otherwise return the answer, right? So we are doing what? That firstly we are creating the groups of our graph and also we are storing the size of each group by using the find and the merge function. So we are finding the union function, right? Next we are finding that if the infected node is the only infected node present in that group. If it is not, then there is no need to remove that node, right? Because the other infected node will again make the entire group infected, right? If it is not true, then find this group which is having the maximum size and which is the in which only one infected node is present. And if you are not able to find the answer, then return the smallest index, otherwise return answer, right? So this is the code. Let's try to run this. So we are getting the answer 0. Now since the test cases and the input output is not updated on this portal, so I am taking the a general input, right? So I am taking a specific input, that is the input is sorry the input is this, that is this is the adjacency matrix graph and this is the initial, right? Initial, right? In this case this is row, this is column. Now these three are representing that all of these nodes are having a self loop to itself. Since it is a directed graph, then all nodes are having the self loop with itself. This is representing that there is a edge between 0 and 1. This is also representing that there is a edge between 1 and 0, right? This is 1 and 0, right? Now the initial are 0 and 1. This means that 1 is also infected and 0 is also infected. Now if I remove 0, then 1 will make 0 again infected, right? If I remove 1, then 0 will make 1 again infected, right? So there is no benefit to remove any of these nodes, right? So this is our this case, that is this case, that is a group infected of parent is having more than one infected node, right? In this case we are doing what, that we are returning the smaller index, right? So the smaller of 0 and 1 is 0, so our answer must be 0, right? These are infected, so our answer must be 0. So we are getting the correct answer, that is 0. Since the test cases and input and output is not handled for this particular question, so that's why it is not going to give you correct answer, right? But the code is absolutely correct, right? So you can try this code on your own. We will soon update the test cases as well as input and output on this portal also, right? So this is all about the code. We are grouping, this is grouping the graph into different groups and also finding the size of all the groups, and then we are finding the size, we are finding the group that is having the maximum size and in which only one infected node is present. So we will remove that infected node. Why? Because we have to minimize the number of infected nodes, right? So this is the code. I hope the solution of this question is clear to you, right? So this is all about how to minimize the malware spread, right? So if you like the content, then give a like to this video. Thank you for watching.